Suppose you had a regression that had as its estimated results what we have here, that the number of kids per family is equal to 0.337 minus 0.135 times education of the parent plus zero point 0.1 times the age of the parent plus 0.664 times whether the parent is female minus 0.045 female times education. So as women get more educated, the number of kids that they have goes down. So that's what that interaction term tells you. As men get more educated, the number of kids goes down, and as women get more educated, the number of kids goes down even further. So for women, the coefficient on education is minus 0.135 minus 0.045, so the relationship is equal to minus 0.18, right? Negative 0.18. So the relationship between education and kids, number of kids, is steeper for females, that's females, and flatter for males. It's negative for both of them, but it's steeper for females. That's what that interaction term is telling you. Now, we can use this equation, which we've estimated, right? And this equation is it can be expressed this way: number of kids equals beta 0 plus beta 1 times education plus beta 2 times age plus beta 3 times whether you're female plus beta 4 times whether you're female times education, the interaction term. So we can use that to predict, well, what's the number of kids, and we can ask, suppose you, if you're a male, so that female is equal to 0. If you're male, f equals 0. If you're a female, f equals 1. We can ask, well, what's the predicted number of kids? And just arbitrarily, because it's going to be easy, you'll see in a second, we're going to say, let's set the years of education 0 and the age equals 0. So now the predicted number of kids for a male, where f is equal to 0, we got an age and education are equal to 0. This is equal to 0, 0, 0, 0, 0. So we just have the predicted number of kids is 0.337. And likewise, we can say that if education and age are equal to 0, but you're a female, then you've got 0.337 plus 0.664. So the predicted number of kids for a female who has 0 education, 0 age, just set those arbitrarily, is 1.001. Why did we set these? Because we wanted to consider another problem. It was a pretty typical final exam problem. Suppose you ran the regression with the dummy variable being male rather than female, so M rather than female. So now you have the same regression, same data, number of kids equals beta 0 plus beta 1 times education plus beta 2 times age plus beta 3 times the dummy variable for whether you're male or not, times beta 4 times the dummy variable for the male times education. So here now we want to know, well, what's the predicted beta 0 hat and beta 3 hat? What are the predicted coefficients that we're going to get on those variables, right? And since we're using the same data, the implication here is we're using the same data, and all we're doing is changing the dummy variable. It has to have the same implication, which is the predicted number of kids. If you're male, 0, and age is equal to 0, and education equals 0, has to be 1.001, because that's what it was predicted in the other regression. And we're using the same data now. All we've done is change the dummy variable. And the predicted number of kids, if you're male, you are indeed a male, and your education 0 and age is 0, that has to be 0.337. So, right, this implies, because that the coefficients of this new estimated equation have to be, beta 0 has to be 1.001, and beta 3 hat has to be a negative 0.664. That way you'll get the estimated outcomes of the predicted number of kids that will be exactly the same as in the earlier regression. So that's how you go about thinking about this problem of what the implication is for the regression if you use the other You recategorize the dummy variable to be 0, 1 instead of 1, 0. So work through this, think about other problems that are similar, and you'll become a master of this dummy variable issue in no time.